Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on September 23, 2025, about 5 days ago. This paper argues that the most reliable signal of good reasoning is the failed step fraction, and shows it drives the biggest pass at one gains. Pruning failed branches boosts accuracy. For example, DeepSeek R1 goes from 20.89% to 29.42%, and GPT-OS 120B rises from 28.05% to 36.41%. The paper is titled, What Characterizes Effective Reasoning? Revisiting Length, Review, and Structure of CoT, and the implications for model training are quite significant. In short, across math and science tasks, the analysis finds that longer thinking and heavy review often hurt accuracy, while lower failed step fraction consistently predicts success across 10 large reasoning models. Alright, the previous segment set up the core claim. Figure 1 shows an example that links raw chain of thought text to a structured reasoning graph, so the metrics become concrete. The left panel labels each chunk as progress or review, which yields length and the review ratio. The right panel converts those chunks into nodes, with red nodes marking failed branches and blue nodes marking successful steps. The figure reports a failed step fraction of 5 out of 16. So figure 1 showed how raw traces become graphs with failed and successful steps. Figure 2 charts the distributions of length, review ratio, and failed step fraction against accuracy for Claude 3.7, Grok 3 Mini, and DeepSeek R1. Shorter chains consistently align with higher accuracy, which counters the longer is better idea. Review ratio is mixed, with Claude trending upward while the others do not. Failed step fraction tracks accuracy most strongly, showing a near linear drop as failure fraction rises. Okay, the previous figure highlighted distribution trends. Figure 3 summarizes conditional correlations across models on both datasets, controlling for question effects, so the colors reflect association strength with accuracy. Length shows mostly negative correlations, meaning shorter chains tend to be more correct. Review ratio appears mixed, with only patches of positive association. Failed step fraction stands out as consistently strongest, since lower failure fraction aligns with higher accuracy across every model and both tasks. Well, the previous figure summarized conditional correlations. Figure 5 presents causal test time selection. The figure compares 4 selectors across models, and failed step fraction delivers the highest pass at 1, with roughly 5 to 13% gains on AIME 2025 and consistent boosts on GPQA Diamond. Error bars quantify bootstrap uncertainty, which still shows clear separation. The left panel covers math, while the right panel shows science, and both rank failed step fraction on top. Alright, the previous figure showed selection gains. Table 1 tests direct editing. The table reports accuracy when the failed branch is kept, removed, or replaced with a short summary, evaluated at the first and last failed points. Removing the branch raises success by about 8 to 14% for DeepSeek R1 and GPT-OS 120B, which signals that failed explorations bias later steps. Summaries help, but less than full removal, so pruning beats recounting. Baselines are lower at the last failed point, yet the relative lift remains strong. Wrapping up, 2 takeaways stand out. Lower failed step fraction best predicts correctness, and longer chains with heavy review often reduce accuracy. The broader implication is clear. Focus on structure-aware tactics like selection, pruning, and concise summaries, rather than indiscriminately spending more test time compute. Thanks for listening. I am Alex, and this was the AI Research Roundup.